Okay, probably gonna have to finish this tomorrow because it's about the witching hour here. Okay, all right, so here we go. So why do you swing your arms when you run? And why is her front leg out? Her right leg is out and her left arm is out, is forward. Why not have the right arm and the left? We'll try and walk that way. You'll keep spinning around. You won't get anywhere. You kind of do the Frankenstein. In fact, that's the way we do the Frankenstein walk. You know, is we. But by flinging this, by flinging the leg and flinging this arm, this creates a torque that wants to twist her body to the right here, twist it this way, and her arm wants to twist her body this way, and so they counterbalance each other, keep you going in a straight line. That's why you swing your arms. It also helps project your center mass down the road. All right, so here's an interesting thing. A battleship simultaneously fires 2 shells at enemy ships. If the shells follow the parabolic trajectory shown, which ship gets hit first? Ship B or ship A? If you've had my course before, if you've had Physics 210, I hope you knew the answer to this. If you've never heard anything about projectile motion before in your life, there's no way you can answer that. Intuitively, you're going to say, oh, A is closer, so it should get hit quicker, even though it's going up higher. Wrong. It's B. The answer is B. And the reason is, once this shell leaves, say there's 2 guns right next to each other there, you can't see them. Once this shell leaves this gun and it's going along this path, the only acceleration that happens to it is due to gravity. Okay? And so everything's in the Y component, is in the up and down part. And this up and down is not very high. In other words, it's just like because it's just like if I throw a ball straight up in the air. If I asked you which ball is going to be in the air longer, if I just threw it straight up instead of going, because the X component does not matter. It doesn't change. We're shooting on the ground, on Earth, so it's gravity is what matters. And gravity is pulling it down. So if I just had a ball right here and I threw it this high, if I had a ball right here and threw it way up here, you'd go, oh yeah, well this ball is going to stay in the air longer. So yeah, so is this shell, because the X part of it has nothing to do with bringing it down to Earth. It's all in the Y part. And then when we throw an object horizontally off a building, notice what happens. The X part stays the same the entire way down. The Y part gets bigger and faster as we go down. Here's a projectile motion that's shot this way. Notice the X part, the velocity stays the same the entire time in the X direction. But the velocity in the Y direction, because see, we hit this thing this way, and what happens is, notice as it's going up, the Y part gets smaller, until it's 0 at the very top, and then the Y part gets bigger, because when we add these 2 vectors together, going crossways, downways, that vector, crossways, downways, that vector, so this vector is getting bigger and bigger as it's coming down. All right, the range. Now, this is a textbook answer. This is not in real life. This is the textbook answer. This is not a real life situation. Okay? Notice, a 15-degree ball won't stay in the air very long, but it'll go the same distance as a ball hit at 75 degrees if they're struck with the same speed, if they're struck with the same initial speed. All these have the same initial speeds. So one hit at 30 degrees will go this far. Now, however, the optic is now 45 degrees, but it is, you'll see what it is. I think you'll see it's 34 degrees. All right, now, go watch the long jump video. This is the one that says the how-to long jump, because there's a few questions from your little mini lesson that you're going to have to answer. It's in that long jump video. And this is going to be sexist old man comment, maybe. I don't mean for it to be. But if I had a PE teacher that looked like this young lady who's teaching the long jump here, I wouldn't have skipped PE so much. Anyway, just saying. All right, out here. So that ends this part.